Section 5.2 is on bisectors of triangles. And since a triangle has three sides, it also has three perpendicular bisectors. So that is where we draw a line straight right out of the middle of each side, and then it would meet in the middle at a certain point. Three vocab words here: concurrent, when three or more lines intersect at one point. The point of currency is that point where they intersect. And the circumcenter of the triangle is also called that point of currency. Next, we have the circumcenter theorem, and that is saying that the circumcenter of a triangle is equidistant from the vertices of the triangle. So when we find the midpoint of each side of the triangle and draw a line into the middle, the point where those three sides would meet is the point of currency there. And then you can also draw from the vertices of the triangle, and those will go through that point too. But they're saying blue lines here are all the same length. And then here, oops, depending on what type of triangle you're working with, that circumcenter point can be inside the triangle or outside of the triangle, or actually on one of the sides. So an acute is inside, obtuse triangle, that point is outside. In the right triangle, it's on the hypotenuse. Next vocab word here is circumscribed, and that is the circle that contains all the vertices of the polygon. So if you were to draw a perfect circle using the 3 points of the triangle, that is what we're talking about there. So for example 1 here, it says KZ, LZ, and MZ are perpendicular bisectors of triangle GHJ. Find HZ. So if we find here, we need to find this length. As you can see, that is a segment coming out of the vertice, and we just talked about how those were all the same distance. So these three lines here all have the same distance, and GZ is labeled 19.9. So then HZ and that ZJ there have to be 19.9 as well. Example 2 says find the circumcenter of triangle RSO with the vertices given. So I've already drawn or plotted the points to make our triangle. 2 of the sides of this triangle lie on the X or Y axis. We are easily able to figure out the center parts of each side here. So this one, the bottom, the base here is 6 long. So the center would be at 3. And then going up, that's 4. So the center would be at 2. So the perpendicular bisectors here, we would have this line, which is X is -3. And then we have this line, which is Y is 2. So they meet at our circumcenter, our center point there. And the question wants to know what is the ordered pair for that point. So that would be -3, 2. All right, the incenter of a triangle is the point of currency of the angle bisectors of a triangle. So the incenter theorem says that the incenter of a triangle is equidistant from the sides of the triangle. So now we're talking about those 3 blue lines that you can see in the picture there, that those are all the same length to the center of that center point P. The incenter is always inside of the triangle. So an acute, obtuse, and right triangles are shown here. As you can see that those points are always inside of the triangle. A circle inscribed in a polygon intersects each line that contains a side on the polygon at exactly 1 point. So over here on the side, there's a triangle. That circle is on the inside. So it meets at, its center is that point there, O. All right, so for example 3, JV and KV are angle bisectors of triangle JKL. Find each measure. And A wants the distance from V to KL. So here is V, and the distance to KL. So over to there. So we are shown here that from V to JK is 7.3. So remember these three, this line included here, are all the same measures. And as you can see, I didn't do a very good job of hand drawing this triangle to make them all look the same. So, but this line here, the pink line and the two blue lines all should be 7.3. And then we have to find the measure of angle VKL. So V to K to L. So we're looking for, let me erase some of these lines. We're looking for this angle measure here. So looking down here at this angle, we have an angle bisector going through angle J there. One side of it is 19, so the other side of it has to be 19. So this whole angle has to be 38 degrees. And then we were given that this angle is 106. So if we add those together, we get 144. And if we take that away from our 180 to see what's left, we have 36. Now, if we go back here, all of this has to be 36. So we're going to have to divide it by 2 because there's that angle bisector there. So 36 divided by 2 is 18. So the measure of the angle they're asking, measure of angle VKL is 18 degrees.